So I'm going to briefly look at the basics of equivalent fractions. So in this video, we're going to look at what is meant by an equivalent fraction, how to determine if two or more fractions are equivalent by simplifying them, and look at how to generate a set of equivalent fractions. The main skill you will need is to be comfortable with multiplication tables. Here are a set of fractions. Look at the relationship between the numerator, that's the top number, and the denominator, that's the bottom number, of each fraction. What do you notice about the relationship in each case? Well, you've probably noticed that the denominator is 2 times greater than the numerator. So if we look at 4/8, 8 is 2 times greater than 4. For 12/24, we can see that 24 is 2 times 12, and so on for 10/20ths and 50/100ths. Because for each fraction the denominator is 2 times the numerator, these fractions are equivalent to a half. And if we look at a half, we can see that the denominator is 2 times greater than the numerator, or the numerator is half the denominator. Another way of determining whether a set of fractions are equivalent or not is by simplifying them. If they all simplify down to the same fraction, then they are all equivalent. To simplify a fraction, I have to divide the numerator and the denominator by the same amount. If I don't do this, then the relationship between the numerator and the denominator will be affected, and the size of the fraction will be affected. So if we look at 4/8 as an example, now because I'm comfortable with my multiplication tables, I know that 4 goes into 4 and 8. So if I divide the numerator and the denominator by 4, well, 4 divided by 4 is equal to 1, and 8 divided by 4 is equal to 2. And there is 4/8 in its simplest form, a half. And we can repeat this for the other 3 fractions. So for 12/24, if I divide top and bottom by 12, I get a half. In the case of 10/20, if I divide top and bottom by 10, I get a half. And for 50/100, if I divide top and bottom by 50 this time, I get a half. It is important to remember that the size of a fraction is determined by the ratio between the numerator and the denominator. It is this relationship that determines whether fractions are equivalent or not. Let's look at another example. Here is another set of fractions: 6/8, 12/36, 25/75, and 8/24. Again, do you see a relationship between the numerator and the denominator? You may have noticed for each case that the denominator this time is 3 times greater than the numerator, or the numerator is a third of the denominator. So looking at 6/18, 18 is 3 times greater than 6. For 12/36, 36 is 3 times greater than 12. And the same applies for 8/24 and 25/75. So these fractions are equivalent to a third. And again, if we weren't sure whether a set of fractions were equivalent or not, we can simplify each fraction. And if they simplify to the same fraction, then they are equivalent. Here's the working to show that each of these fractions are equivalent to a third. And because they're all equivalent to a third, these fractions are all equal. So what about these fractions? Are these equivalent? Again, this is about knowing your multiplication tables. I'm going to simplify each fraction. And if all the fractions simplify to the same amount, then they are all equivalent fractions. That is, they are all the same. I'll begin with 6/8. Now, I know that 6 and 8 are divisible by 2, they're both even numbers. So if I divide the top and bottom of 6/8 by 2, I end up with 3/4, because 6 divided by 2 is equal to 3, and 8 divided by 2 is equal to 4. Looking at 15/20ths, well, 5 goes into both 15 and 20. So if I divide the numerator and the denominator by 5, again I end up with 3/4. 15 divided by 5 is equal to 3. 20 divided by 5 is equal to 4. For 21/28ths, I happen to know that 7 goes into 21 and 7 goes into 28. So if I divide the numerator and the denominator by 7, I have, 21 divided by 7 is equal to 3, and 28 divided by 7 is equal to 4. Again, we have 3/4. And finally, 27/36. I happen to know that 27 and 36 are both in the 9 times table. So if I divide 27 by 9, I get 3, and if I divide 36 by 9, I get 4. So we end up with 3/4. Let's just say you didn't immediately think of 9 going into 27 and 36, but you did know that 3 went into 27 and 36. So if I divide 27 by 3, I get 9. And if I divide 36 by 3, I get 12. So I end up with 9/12. I haven't simplified 27/36 to its simplest form, as I can see that 9/12 can be divided further. 9 and 12 are both in the 3 times table. If I divide 9 by 3, I get 3. And if I divide 12 by 3, I get 4. So I end up with 3/4. I can't simplify this fraction any further. Look at the two approaches for simplifying 27/36. They both produce the same result, but in the first approach, I divided top and bottom by 9, which produced the fraction 3/4. But in the second approach, I initially divided top and bottom by 3, and this produced the equivalent fraction 9/12. But this isn't the fraction in its simplest form, so I divided by 3 again, and this produced the result 3/4. So here, when we divided by 3 and then divided by 3 again, it produced the same result as dividing by 9. So by simplifying these 4 fractions, we produce the result 3/4. These 4 fractions are equal to each other, they are all equivalent, and they are all equivalent to 3/4. The key to this kind of work is, of course, practice and knowing your multiplication tables. The final thing I want to look at is generating equivalent fractions. This is very straightforward. To generate a set of equivalent fractions, all you do is multiply the numerator and the denominator by the same amount. So if we look at a half, if I was to multiply the numerator and the denominator by 2, I end up with 2/4. If I was to multiply the numerator and the denominator by 7, I end up with 7/14. So I've generated 2 equivalent fractions that are equal to a half, that is 2/4 and 7/14. And we know they are equivalent because the denominator is 2 times greater than the numerator. If I had 5/7, if I multiplied the numerator and the denominator by 3, I end up with 15/21. If I was to multiply the numerator and the denominator by 12, I end up with 60/84. So 15/21s and 60/84 are equivalent fractions. They are equivalent to 5/7. So there's a basic introduction to what equivalent fractions are, how to simplify fractions, and how to generate equivalent fractions. Remember that the value of a fraction is determined by the ratio or the relationship between the numerator and the denominator, and equivalent fractions share that same ratio. But that's all I'm going to be covering in this video. Thank you for watching.